Hi everybody, hope you're all doing well. We're going to move to the last section of 5.7, the last part of 5.7, looking at the applications of quadratic equations. Now we have already looked at two different types of applications. The first one was dealing with the area of a rectangle and following the formula A is equal to LW. And then the second application that we looked at was the Pythagorean theorem, and that was C squared is equal to A squared plus B squared. And as you might remember, in both of those cases, when we were solving the quadratic equation for the dimensions of the rectangle as well as the sides of the right triangle, we had to reject any negative values that we got. We could only accept positive values. Well, as we move to the third and final application problem of quadratic equations, we again will not be able to allow negative answers to be a part of our solution set. We'll only be able to take positive answers. Now, this third application problem is a little bit different because we really won't have to follow a four-step plan in solving the problem. And the reason is the equation is going to be given to us. We're not going to have to determine what the equation is. We're going to be presented with the model. We're going to be presented with the equation. Now, the category of this type of problem is called a mathematical model. Now, the definition of a mathematical model is this. It is a situation where an equation, or let's say a function, written as an equation, but I'll say the word equation. It's where an equation is discovered or devised that describe real-world phenomena. And this function that gets described and proved out to be true is purely based on the type of problem that is being done. So as we go to problem number 1, that's going to depict a real-life phenomena kind of situation that could really be seen, this formula, this model that you're going to see written up on the board, is a model that has been created specifically for this type of problem. Not some other type of problem, but for the type of problem that's going to be stated to us. We call it a mathematical model problem. So we're really not going to require the four-step plan whatsoever to solve this particular problem. I want us to look at this model up on the board first, and I'll kind of speak about it just a little bit before we actually go to the problem. You'll notice that this function is quadratic because the polynomial expression on the right-hand side has as its degree a degree of 2. And any variable term that is taken to a power of 2 is called the quadratic term. So we're looking at a quadratic function here. And this happens to be the model that has been discovered. It wasn't just there to begin off with. It was discovered and devised to fit a particular kind of real-life situation that has occurred. And this experiment was done over and over and over again to really finalize this particular kind of a function that we're going to be dealing with. Now, before I leave this for a moment and go to the actual problem, I want to speak about two concepts of this quadratic function. The h of t, or the value of function h when the domain is t, the h of t, as I wrote up there in the upper right hand corner, is going to represent the height of the ball in feet from the ground. So it is really important in going through this problem that you understand what the h of t represents. It's more than just the name of a function and the domain of t. The h of t in this model stands for the height of the baseball in feet from the ground. And then the other key concept is the domain of t. The t, the domain, stands for the number of seconds after the ball has been thrown. YT, T for time. Time in seconds. The number of seconds after the ball was thrown. Okay, so those are key to the problem. Now let's go to this first real life phenomena kind of a problem that is being given to us. A Little League baseball player. So right now off of the bat, if he's Little League, he's going to be about 10 years old, maybe 9, 10, or 11 years old. Just not important, but the age, just to give you kind of an idea. You see, by the way, this model that I just went over, it would not fit if we were talking about an older youngster. It fits for a Little League baseball player. Not for a college baseball player, but a Little League. A Little League baseball player throws a ball upward from where he happens to be standing on the ground. The height of the ball from the ground in feet, h of t. I've already defined for you what h of t is standing for. H of t represents the height of the ball from the ground in feet. T seconds after the ball is released is given by the function h of t is equal to a negative 16t squared plus 30t plus 4. There is the data. Now, the questions. There will be 3 of them. Here's the first one. What is the initial height of the ball? Now, when the question is asking for the initial height of the ball, that is standing for what is the height of the ball as it is resting in the hand of the Little League player. The ball hasn't been thrown yet by him. It's resting in his hand. How do we know it's resting in his hand? Because question A is saying, what is the initial, the beginning height of the ball? Well, the beginning height of the ball is when the ball is resting in his hand. He hasn't thrown it yet, so no time has elapsed off of the clock. No seconds are ticking away because it hasn't been thrown. Notice what it says up here, t seconds after the ball is released. Well, in letter A, it's asking for the initial height of the ball. It hasn't been thrown yet. So no time has come off of the clock yet. There's no seconds that have elapsed. So let's come back over here to our model, and we're going to handle letter A. Letter A said, what is the initial height of the ball? They're wanting this. This is the height of the ball from the ground. And that's what they're asking. What is the initial height of the ball? So to find the initial height of the ball, we have to identify a time. We have to identify a number of seconds that are going to be elapsed. Well, there aren't going to be any seconds that are elapsed because the ball is resting in the hand of the Little League player. He hasn't released it yet upward. He hasn't thrown it yet. It's in his hand. So the initial height is going to be based on the fact that there is no time that has elapsed. There's no seconds that has elapsed. So the value of the domain, the t, is 0 seconds. So we're going to evaluate this function for when the time is 0. 0 seconds elapsed. So here's the little process for letter A. The value of h when the time is 0 is equal to, wherever we see the t, we're going to put in that domain of 0. -16 times 0 squared plus 30 times 0 plus 4. Let's come down and do the mathematics. 0 squared is 0. I'm going to condense this real fast. -16 times 0 is 0, plus another 0, plus 4. And now we'll express our answer. The value of function h when its domain is 0 seconds is going to elicit a range value, or the initial height of the ball will be and if you kind of look right here, he's standing on the ground. This is ground. The ball is in his hand. The height of the ball from the ground at 0 seconds of time is 4 feet. And that seems to be pretty logical. You're talking about a 10-year-old boy, and he's just holding on to the ball. The point of where he's holding on to the ball, it's 4 feet from the ground. Is it going to be exactly 4 feet? No, but it's a good estimate. So let me give you a clue on future problems of this kind of a model. When they are asking for the initial height, I'm going to repeat those two words. Initial height. Initial height. When they're asking for the initial height of the object, the domain, or the period of time, will be 0. 0 seconds. That's letter A. I'm going to erase, not the model. There's A. Now let's go to B. Same premise up here. Same little leaguer. When. Letter B. When. Notice, it's not saying what is the height. It says, when is the ball 18 feet above the ground? They've given us the number of feet above the ground. This h of t represents the height of the ball from the ground. So this time on letter B, they're telling us h of t. It's 18 feet. And the question is asking, When is the ball 18 feet above the ground? When means after how much time? It could mean maybe the time on the watch or on the clock, but we don't know that because we don't know the time of day when he's throwing it. When it says when is the ball, when is referring to the tee. How many seconds will elapse for when that ball is going to be 18 feet above the ground? Now you see, before he throws it out of his hand, that ball is already 4 feet off of the ground. So now he's going to launch it. Now he's going to throw it. And here's the idea. He throws it, and he's throwing it upward. And it's probably not going to take that long on the journey up. I'm just kind of stopping maybe right about here, to where that ball is going to be 18 feet from the ground. So he's going to throw it. And it very likely is going to reach, at a certain number of seconds, 18 feet from the ground. But it just might likely continue to go up. And then by the force of gravity, it's only going to go up so high because of the strength of the youngster, and the ball is going to then have to come down. Let's see what happens in our model, and then we'll talk a little bit more about it. On letter B, when is the ball going to be 18 feet above the ground? We know the h of t is 18. And now we just copy the trinomial on the right-hand side. And we have a quadratic equation. And now we're going to solve the quadratic equation. Now, people, you can do one of a couple of things. You can move the 18 over to the right-hand side, thereby getting a 0 on the left, which we need to do because we need to get it into standard form. Or you can move all three terms of this trinomial from the right-hand side to the left and have your 0 on the right-hand side. If we put all of the terms over the left, the coefficient of the negative 16t squared will become a positive 16t squared. But we can still get rid of that negative sign by factoring. So I'm just going to move the 18 from the left over to the right. It's not going to be a big deal. Negative 18 is equal to a negative 18. And I'll draw the line. And we'll have 0 is equal to a negative 16t squared, positive 30t, minus 14. Now, definitely one thing that we're going to do, if there is no major GCF, and there is, but if there wouldn't be, we would certainly get rid of that negative sign by factoring out a negative 1. But 16, 30, and 14 are all even. So they're all divisible by 2. Now we just want to make sure that there isn't some number bigger than 2, and I don't believe there is that will go into all three, because 4 won't go into 30 nor 14, and I don't think any other number other than 2 will work. Now because he begins off with a negative, when we take out that GCF, we're going to take the negative sign down as well. So now here's the way that I'm going to look at it right here. Let's factor out a negative 2. I'm going to make a bracket as opposed to a parenthesis. Negative 16t squared divided by negative 2, 8t squared. Positive 30t divided by negative 2, a negative 15t. And negative 14 divided by negative 2 will be a positive 7. Now this trinomial that's inside the bracket is going to have to be factored. I look at the coefficient of the quadratic term because it's going to tell me whether I'm going to use AC or not. And we're going to use AC because the coefficient of t squared is not 1. So, maybe just kind of off to the side right here, I kind of use an X. Some of you might use a device called an eye chart. It doesn't matter what you use. Some of you might not use any of it. You'll just factor. I'm going to use him. This is 12 o'clock, 6 o'clock, 9 o'clock, and 3 o'clock. Let's go into it. The 12 o'clock region contains the middle term of the trinomial. The 6 o'clock region is where we put the result of multiplying A, which is 8, times C, which is 7. 8 times 7, that's a positive 56. People, I cannot emphasize it enough when using the AC method. The sign of the AC is critical. That opens up the whole door. If AC is positive, that means the term in the 9 o'clock region and the 3 o'clock region have to have the same signs. And they will have the sign of the middle term. So I'm going to stick the negative there and the negative there. And then we're going to identify two factors of 56 that when really added together, why really added? Because the sign of the last term is positive. That when really added give us 15. And it doesn't take an Einstein. 8 times 7 is 56, and 8 plus 7 is 15. So, in the 9 o'clock region, we'll go ahead and put the negative 8t. And in the 3 o'clock, we'll put the negative 7t. If you combine the negative 8t with the negative 17, bullseye. And a negative 8 times a negative 7 is a positive 56. Now let's roll into our factoring by grouping setup. Bring down that GCF of negative 2. Expand the bracket a ways. Bring down your first term. Then we'll bring in, either one would fit, it doesn't matter. We'll bring in 9 o'clock. Negative 8t. Then bring in 3 o'clock. Negative 7t. And then the last term of the trinomial. Why did I use a bracket? So I can use parentheses to form my binomial groupings. Tuck the front pair, tuck the back pair, stick a plus sign in there. Let's come down. 0 is equal to negative 2. Once again, make the bracket. I don't want to erase all of that right there, but in that first grouping, let's take out the GCF of 8t. Make a house. Divide each one of these terms by 8t. We'll have a t minus 1. Over here, take out a negative 7, because he begins with a negative. Negative 7, and by golly, we're going to get a t minus 1 there and close it off. Now we'll bring down our completed factors, and then we'll determine our answer. Bring down that 0 is equal to negative 2. The first binomial factor will be the common binomial factor of t minus 1 that appears in both of those. So we'll pull out that t minus 1 and make your second binomial grouping, and the other one will be made up, like we've said over and over and over again. We're going to bring in the turkey and the gravy. 8t minus 7. Now let's use the zero factor property to get our values of t. And remember, If any one of the values of t is negative, it's rejected, because the period of time can only be a positive number of seconds. So if we come down, we don't need to do anything with the GCF of negative 2. We do not set that negative 2 off equal to 0 because it is not connected to a t. If it were, we would, but it's not. These are the only two. So we'll write down t minus 1 and set it equal to 0, or 8t minus 7 and have it equal to 0. This one, if we add 1 to both sides, t is equal to 1 second. So that is telling us, number one, that after the ball was immediately thrown by the Little League baseball player, after 1 second, that's not very long, after 1 second, that ball is going to be 18 feet off of the ground in 1 second. But we've got this one as well to deal with. Positive 7, 8t is equal to 7 over 8 over 8, and t will be equal to 7/8 of a second. Now 7/8 of a second is a smaller amount of time than 1 second. They're both positive answers. Here's what this means. You have two answers for this problem for when that ball is going to be 18 feet from the ground. Now, I erased the little fella right here, but you can see him right here. He has thrown that ball. And in a matter of 7/8 of a second, almost a full second, but just short of it, that ball, let's say, has reached there, and from the ground to that point is 18 feet. But you see, people, when he threw that ball went at its highest point, it went a little bit higher than 18 feet, but probably not too much higher, and then it came down again. And when it came down again on its downward journey, it was going to be 18 feet again on its downward journey, and that's going to appear after a second. Not a second after it hits the initial 18 feet. No, it's a real quick move. After 7/8 of a second, it's at 18, and then click, after a full second, it's at 18 feet again. So there's two answers for that given problem. Are they exactly at those times? No, but they're close enough. They're close enough. And then there's one final piece to this. So we'll erase everything but the model. And we'll go to C. Same scenario. Here's the question. How long does it take? I'm stopping right there. How long does it take? They're not asking for height on letter C. They're asking for t again. They're asking for time. They're asking for the number of seconds. How long does it take for the ball to hit the ground? And this is the concerning one. And I understand why it's a concerning one, because it's a little bit more abstract. It's not giving you a designated number of feet off the ground. It just says, how long does it take for the ball to hit the ground? I take you back to this. If they're asking us to find out how long it's going to take for the ball to hit the ground, they're wanting us to find t. Well, then if they're wanting us to find t, they have to tell us the h of t. They have to tell us the height. And the only hint that we have for the height is what it's asking. How long does it take for the ball to hit the ground? The kid is here. Here's the ground. He throws the ball. We're not asking for the height anywhere here. We're not asking for the height anywhere here. Not here. Not here. Not here. We're asking how long will it take for the ball to touch the ground? What will be the height of that ball from the ground when it touches the ground? Remember what the H of T stands for. Height of ball in feet from ground. Well, when the ball hits the ground, that's what they're wanting us to find out how many seconds. When that ball hits the ground, how far off of the ground, how far away from the ground will that ball be when it hits the ground? It'll be 0 feet from the ground when it hits the ground. When it hits the ground, how far away is it from the ground? Nothing. So on letter C, how long does it take for the ball to hit the ground? Your value for your height is not 4. It's not 18. It's not 19. It's not 9. It's not 7. It's 0. It's 0. Copy that. Oh, I hope you see that. You rewind that tape, you send it back, and you look at it again, because you want to make sure that you know that. Bring down that 0 and that equal sign. Let's take out the GCF. A -2. Pull it out. That'll give us 8t squared. A -15t and a -2. He's an AC. I'm going to get it ready. -2, I'm going to a bracket. $12, -15t. AC, +8 times -2. People, I'm glad it happened. When AC is negative, that automatically means that the signs for the 9 o'clock and 3 o'clock regions are opposite. One's positive and one's negative, and it doesn't matter which one you assign to what. But I ordinarily do this when one has to be positive and the other one's negative. I ordinarily let the 9 o'clock region carry the sign of the middle. Then 3 o'clock has to be positive, because only a negative times a positive will give a negative. Now, we need to come up with 2 factors of 16 that, when really subtracted from one another, will give us 15. Well, that's got to be 16 and 1, because 16 times 1 is 16, and 16 minus 1 is 15. The larger factor between the 16 and the 1, the larger factor 16, has got to carry the sign of the middle term. -16t added with a +1t, bullseye. Negative times positive, bullseye. Now let's write it. 8t squared. I'll bring in 9, -16t. I'll bring in 3, plus t, and then -2. Bring down that 0 and the equal sign, bring down that -2, make your bracket, and let's go in and make our groupings. The front pair, the back pair. Let's pull out the GCF out of the front. We can pull out an 8 and a t. That is going to leave us with a t minus 2. This puppy, he's only got a 1. And he's got to be a positive one that you pull out, and that's going to leave that with a t minus 2. And now let's bring down our factors. 0 is equal to negative 2 times the quantity of this common binomial factor of t minus 2. And then the other factor will be made up of this piece of turkey and this little splash of gravy. A negative, excuse me, that should have been a negative 2t. Sorry. No, yeah, it is. This should have been a negative 2t right here, folks. I'm sorry. Where is it? Yeah. All right, Kent, come on. 8t squared minus 16t plus the t minus 2. Pull out that GCF. No, I'm looking wrong. We're fine. We brought down that GCF of t minus 2. Your other factor is going to be made up of this turkey and that gravy. And now let's come back and let's set each one of these off to 0. T minus 2 is equal to 0. 8t plus 1 is equal to 0. We'll get this one out of the way first. That's a negative 1 on both. And we'll have 8t is equal to negative 1. And we divide both by 8, and we get t is equal to a negative 1/8 second. It can't be negative. That one's rejected. But this one right here, positive 2 on both, the amount of time that will have elapsed will be 2 seconds. And you see, after he throws that ball, after a period of time of 2 seconds, it will have hit the ground, and that is exactly what we wanted to see on there. So I apologize for that little bit of a lull right there, but we're all right. We're human. You and I both are. You take care of yourself, folks, and we'll move now into the next segment of where we've got to go, and we'll join you later. Have a good day. Bye-bye.